we're going to talk from there about half-life problems, all right, because that's what the next step is with nuclear isotopes. So first of all, let's just talk about what half-life is. You ran through a simulation now with it, dealing with pennies and pretending that those are isotopes that are decaying. So half-life is simply the amount of time it takes for half of a substance to decay from its parent isotope into its daughter isotope. So key things here to recognize is that we're talking about a parent isotope. Christopher, will you shut that door? And we're talking about a daughter isotope. All right, so our parent isotope is the isotope that we're starting with. And our daughter isotope is our ending isotope. So for the simulation that you guys just did, the heads up pennies represented our parent isotopes, and the tails represented our daughter isotopes. You guys don't need to write this down. I already know how to do it. Alright, so there's two different types of half-life problems. The first type is what we call a quantity problem. So by quantity, we're talking about how much might remain. All right, so let's look at an example of this. Let's say it says iodine 131 is used to destroy thyroid tissue in treatment. The half-life is 8 days. If a hospital receives a shipment of 200 grams, how much would remain 32 days later? so the first thing that we want to do is pull out our important chunks of information. All right, and that's usually going to be our number values. So it's important to know what the half-life of something is. So the half-life is 8 days. Then it also tells me that I started off with 200 grams of iodine. And it wants to know how much would remain 32 days later. So I have 2 day values and I have 1 mass value. Now, the first thing that we're going to have to do in any of these problems is figure out how many half-lives have actually taken place, all right? So in the lab that you guys just did, you guys did the half-lives to figure out how much would remain. So this one is kind of setting up and telling us we've gone 32 days, how many half-lives have actually occurred. So in order to find our number of half-lives, you're going to simply take the time covered and divide it by a half-life. So the amount of time being covered in this problem is 32 days. It wants to know how much would remain after 32 days. And 1 half-life, it told us, was 8 days. All right, so 32 divided by 8 is 4. So I now know that I've had 4 half-lives that have taken place. So the next thing is to run our simulation, basically, with our half-lives. Now, when we start with half-lives, we're going to always start with 0. So I usually put 0 at the top. And at 0 half-lives, how much iodine did we start with? 200. So at 0 time passing, I started off with 200 grams. It says I underwent 4 half-lives. So I know that I'm going to undergo...
Please excuse this interruption. At this time, Colonel Kings, Miss Nelson, and Coach Shocks home with me to report to the Media Center. Colonel King, Miss Nelson, and Mr. Shocks home with me to report to the Media Center at this time.
I know that I'm going to undergo 4 different half-lives. So we already saw this in your lab simulation. So at 1 half-life, how much of something is left over? Half of it, right? So if we started with 200 grams, at 1 half-life, how much would be left? 100. All right, so at 2 half-lives, how much of that 100 would be left? At 2 half-lives, how much of that 100 would be left? 50. So at 3, I would have 25. And at 4 half-lives, I would have 12.5. So at 4 half-lives, how much would remain? 12.5 grams of iodine would be left. Yes. So for every half-life, I just divided it out by 2. And 12.5 then would be my answer. right, let's look at another one. All right, number 2 says technetium 99 is used for brain scans if a lab ships 150 grams, how much would remain after 18 hours if technetium 99 has a half-life of 6 hours. So I'm gonna find my chunks of information. So I'm shipping out 150 grams. I'm looking for how much would remain after 18 hours. And my half-life this time is 6 hours. So first thing I want to do is figure out my number of half-lives. So number of half-lives equals the time that's covered, which is what? 18 hours, divided by 1 half-life, which is 6. So how many half-lives have taken place? 3. All right, so my next thing would be to draw my chart. So at 0 half-lives, how much did I start with? 150. And I'm going to have 3 half-lives this time. So at 1 half-life, how much would I have? 75. At 2? 37.5. And at 3? 18.75. And that is grams. So how much would remain after 18 hours? We'd have 18.75 grams.